Yeah, good evening, everyone. Welcome back to another project presentation by 360DigiTMG. Today, we are going to see the project about retail analytics, price optimization model. So we prepared the project under the guidance of Mr. Sharath Manikanda and Mrs. Gomati Chakravarti, and we are sincerely thanking 360DigiTMG for providing us this opportunity. Next slide. So following are the team members who have contributed to the project under the guidance of the mentors. I'm Rishal K. Faisal and my teammate Amal Joseph John. So these are the contents included in the presentation: project overview and scope, project goals and constraints, CRISP-MLQ methodology, technical stacks, system requirements, project architecture, data dictionary, data pre-processing, model description, steps involved in price optimization, data for processing, code for price optimization, graphical representation, model deployment strategy, output of the deployed model, challenges, future scope, and references. Coming to project overview and scope, price optimization is a method of determining the best price or set of prices for your business offerings. Bad pricing decision cost big money for businesses. By the help of machine learning, predicting a better price for products is reliable than human interventions. Price optimization estimates the impact of pricing on sales, performance, and then fixes a price that is best suited for the objectives of the retail companies. Price optimization in retail helps businesses in analyzing the buying patterns of customers and their performances for pricing. Thus, a quick and viable pricing decisions can be made with the aid of price optimization. Next few slides will be presented by my teammate Amal.
Good evening, everyone. I'm Amal Joseph John, and I'll take you through the next few slides. The objective of the project is to find an optimized price for products of a retail store. With this selling price, the company should sell maximum units and also generate maximum revenue. The constraints we face in this project are the fluctuation of demand. The demand for a product in the market may affect the optimized price. Price of raw materials. Cost of raw materials may keep changing, so a regular update in the optimized price is required. Lack of data. Lack of data might result in reducing the accuracy of the model. A higher accuracy can be achieved with a better collection of data. Next slide, please. Now let's discuss about CRISP-MLQ methodology. CRISP-MLQ is short representation of cross-industry standard process for machine learning with quality assurance. It is a systematic process model for machine learning software development that creates an awareness of possible risks and exercises quality assurance to diminish these risks to ensure planned project success. Here are the 6 steps of the methodology. First is business and data understanding. Here, we try to find the basic business goals and set up the objective to reach the goal. Our basic goal here is to find the optimized price of the retail products in the store to increase the profitability of the store. Then comes data understanding. Here we find out what type of data we should involve to build a project. In this project, the data was already collected through primary sources and made readily available for our use. The data consists of monthly transactions of different products of a retail store. Second step is data engineering, also known as data preparation. Here we try to do data pre-processing, data cleaning, and convert data to different types according to our project needs. Third step is model building. This is the crucial step among all the steps. Here, we fix the modeling technique to build our required model. In this project, we have used regression techniques to build the model for price optimization. Next is model testing and evaluation. In machine learning, model testing is referred to as the process where the performance of a fully trained model is evaluated on a testing set. And in evaluation, we improve our model based on the test results. In this project, we tested the model we created using regression techniques and improved it on the basis of test results. Fifth step is deployment. We have deployed our project on Heroku, which is a cloud platform as a service that enables developers to build, run, and operate applications entirely in the cloud. The last step is monitoring and maintenance. In our project, since we have deployed it in Heroku provides a variety of metrics tools to help investigate and diagnose issues of the app. Coming to technical stacks, we have used Python to write the source code of the project. We have used different packages like pandas, numpy, matplotlib, stats models, etc. for different purposes like data cleaning, exploratory data analysis, model building, visualization, etc. We have used Spider, which is an integrated development environment for developing the Python code. Spider has editing, interactive testing, debugging, and introspection features. The front end for the web application of our project has been developed using Streamlit, which is a free and open source framework to build web apps. The database system that we have used in our project is PostgreSQL, which is a powerful open source object relational database system that uses SQL language. For deployment, we have used Heroku, which is a cloud platform as a service, supporting several programming languages. Next slide, please. For processing the data we need a system with minimum 8 GB RAM memory, a minimum Intel Core i5 processor, and a Windows 10 operating system. To prepare the environment for developing our code, we need to have Python version 3.8 installed in the system. Also, we need to install Anaconda software to launch the IDE like Spider. We also need to install packages like stat models and Streamlit for developing the model and for frontend. After deployment, we only need a system with working internet connection and a web browser to access the application. The presentation will be taken forward by Risha.
Now let's understand the project architecture for price optimization. Since the client uses PostgreSQL for their database management, firstly, we extract the data from PostgreSQL database using SQL queries and then store the data as a data frame in Python using Spider IDE. We open a connection between PostgreSQL and Python for this purpose. After extracting the data pre-processing is done to remove the unwanted entries and to get the relevant cleaned data. From this cleaned data, we find the best columns to be used in the regression model using correlation analysis and other methods. After finding the suitable independent variables, we go on to build a regression model to predict the number of sales units using the set variables. After building the model, we use the obtained intercept and coefficient values to calculate the units sold by substituting these values in the equation of regression. With the calculated quantity value, we find the revenue that can be generated for a range of different selling prices. From this, we find the maximum revenue generated, which will in turn give us the optimal price. After the development of the source code, we develop a required front end using Streamlit and deploy it to Heroku as a web application. Next slide. Now, these are the different columns in the dataset that was provided. UID is the transactional ID, name is the name of the material, zone is the zone of business, brand is the brand of material, MC is the material category of the product. F date is the month of sale. NSU is net sales unit, that is the total units sold in a month. NSV is the net sale value, that is the total sale value in a month. GST value is the GST on the net sale value, and NSV minus GST is just a calculation column. Sales at cost is cost price on NSU for the retail store. Margin is the profit on NSU, for which there is a relationship between NSV, GST, and sales at cost. The formula has been given on the right side. Margin percentage is the profitability or sales of the company expressed as percentage. Again, formula has been given on the right side. Gross sales is a metric for the total sales of a company, unadjusted for the costs related to generating those sales. Gross sale minus GST is again a calculation column. Gross RGM or gross margin shows the amount of profit made before deducting selling, general, and administrative costs. Gross margin percentage is the gross margin divided by sales, displayed as percentage. MRP is a maximum retail price of the product. SP is the selling price, the price at which the product has been sold at the particular month. DIS is the discount in rupees, and DIS percentage is the discount percentage. After going through the data, we identify the different independent columns and the calculated columns, which can be obtained using the independent columns. For example, the NSV or the net sale value can be calculated as net sale unit multiplied by the selling price. So NSV is calculated from NSU and selling price. So we have sorted the wanted columns and unwanted columns. Now going on to data pre-processing. Data pre-processing is a data mining technique which is used to transform the raw data in a useful and efficient format. In our project, we checked for null values and found 16 rows. After analyzing, we realized that these NaN values were due to 0 sales unit or NSU. Here you can see there are 0 in the NSU columns, which in turn gives 0 for most of the other rows, columns. So in MRP, we have 16. In SP, we have 16 NaN. In discount, we have 16 NaN. So all these 16 rows had no relevance. So we decided to remove them. Next, we found that there were negative values in columns like NSU, sales at cost, MRP, and SP. As these columns have an impact on the efficiency of the model, we decided to remove them. Coming on to EDA part, exploratory data analysis is an approach of analyzing data sets to summarize their main characteristics, often using statistical graphics and other data visualization methods. In our project, we have used SweetWiz, which is an open source Python library that generates beautiful high density visualizations. Here we can see that there are 2,357 unique products in the name column without any missing values. The number of transactions for each product is also displayed on the right side window. Here we can see that majority of the products being sold are of Golden Harvest. Then comes Coplus, Sanki's Kitchen, Desi Atta, Golden Harvest Prime, Karmic, Mother Earth, and so on. Here it is evident that The west zone has more transactions, followed by south zone, north, and east. The number of transactions for each zone is also displayed. You can see that west zone has 13,101 transactions, whereas south, north, and east, and the overall transaction is around 37,437. So till now, we were analyzing the dataset as a whole. Now we take a single product into consideration and plot the heat map to find the best independent values or independent variables. So for this Sanki's Kitchen Punch Forerunner PP50, this is the heat map. Next slide. Okay, coming to model description, ordinary least square or OLS is a common technique for estimating coefficients of linear regression equations which describe the relationship between one or more independent variables and a dependent variable. In simple linear regression, a target variable is dependent upon a single independent variable. Whereas in multiple linear regression, there are more than one independent variables. These are the equations for simple linear regression and multilinear regression. In simple linear regression, y is equal to beta naught plus beta 1 into x plus epsilon. For multiple linear regression, y is equal to beta naught plus beta 1 into x1 plus beta 2 into x2 plus epsilon, where beta naught is the intercept, beta 1 is the slope or coefficient of the first independent variable, beta 2 is the slope or coefficient of second independent variable, and epsilon is the random error component. In our project, we have taken x1 as selling price and x2 as the unit cost, which I will be explaining in the coming slides. Now let's talk about the steps involved in price optimization. As I told, all the calculated columns are removed and the required columns are kept. Taking one product into consideration, after we find the independent variables using heat map, we need to predict the NSU or the net sale unit for this product using regression. Two new columns are added to the data frame for further calculation purpose, which are unit sales at cost and unit GST, UC and UGST. So since the given sales at cost and GST value columns are for the total units sold, we calculate the value for a single unit and store them in the data frame as two new columns. Then a multilinear regression model is created using selling price and unit sales at cost as the independent variables and net sale unit or NSU as the target variable. The regression method that we used here is ordinary least square. From the model, we get the coefficient and intercept values and substitute them in the regression equation. The MRP of the product is taken as the input and we consider a maximum discount of 50% from the MRP. So the range of selling price we consider will be from 50% of the given MRP to the MRP. Now we calculate the NSU for this set of prices using obtained regression equation. Using this NSU, we calculate the revenue and discount percentages. The calculated NSUs, revenues, and the discount percentages are stored in a new data frame. Revenue multiplied by NSU is calculated, and by sorting it in descending order, we get the price at which the best revenue is generated with a good amount of sales unit. In order to verify the findings, we plot the graph of price versus revenue. The peak of the graph gives us the optimal price of the product. Next slide, please. So this is the data for a single product, which is, you can see, Sanki's Kitchen Punch Forerunner PP50G. So there are so many zones available: South Zone, West Zone, North Zones. and F date or the month of sales has been displayed, and the units or the sales unit of each month has been displayed. Also, the GST value has been displayed for this many units. In order to get the GST value of one unit, we have calculated the UGST column. And also, in order to calculate the sales at cost or the manufacturing cost to the company, for one unit, we have created this unit cost column. As mentioned before, these are the relevant columns needed for the price optimization of a single product. The newly added UC and UGST columns can be seen in the data frame. Now I'll hand over to Amal for the next tag.
Next slide. Here we can see the code for
here we can see the code for price optimization. The first line shows the building of the linear regression model with NSU, net sales unit, as the target variable, and SP, the selling price, and UC, the unit cost of a product, as the explanatory variables. After filling the data on the model, we store the coefficients and intercept into a variable. We take the mean of unit cost and GST values and store them for further calculation. Next, the range of SP from 50% of the given MRP to MRP is stored as a list. Further, we declare lists to store calculated revenue, NSU, discount, and discount percentage. For each price in the list of SPs, we calculate the NSU by substituting the respective values in the regression equation as well. Then the revenue is calculated using this NSU value by using the equation for profit, which is NSU into SP minus NSU into cost minus NSU into GST. This can be shortened to NSU into SP minus cost minus GST. Discount is calculated as MRP minus SP. All these values are appended to the respective lists, and after computation for each SP, we create a data frame containing all these values. Next slide, please. So from this data frame, we remove all the rows which contain negative values of NSU or revenue, as these rows are irrelevant. If none of the rows contain a positive NSU and revenue, then an error message saying that given MRP cannot create positive revenue is displayed. Otherwise, we proceed to create a column, revenue into NSU. The optimal price of the product will be the maximum value of this column. In the next lines, we round off the values to 2 decimal places for clarity. And finally, the optimal price is displayed. Next slide, please. Here, we can see the revenue versus selling price graphs for different products. In the two graphs on the first row, we can see that the revenue increases as the selling price increases. This indicates a higher price can also achieve a higher revenue for these products. In the graph shown below, we can see that the revenue falls below zero revenue line or the cutoff line as the price increases. This indicates that above a certain price, the demand for this product decreases, which in turn affects the revenue in a negative manner. So for GH rice pulao 5 kg, the peak of the graph gives us the optimal price where revenue is maximum. Next slide, please. So we have created the front end using Streamlit. First, we set the configuration of the page. Here we have set the page layout as wide and mentioned the title of the web page. Then we display the heading Retail Price Optimization. We have created a container to store the various elements of the application. The container is further divided into 4 columns. Next, we define a drop-down box for category values. Another drop-down box is created for displaying the brands. This drop-down is populated according to the value selected in the category column. Next, a drop-down box for the names of the items is created and is populated according to the value selected in category and brand columns. Another drop-down box for choosing the zone is also defined. After selecting the values for all the drop-down columns, we display the previous MRP range of the chosen item, which the user can refer to while entering the MRP in the input column. We have also defined a button get price, which the user can click after entering all the data to get the optimal price. On clicking the button, the function for optimal price, get price, is called. In this function, a connection is established to the Postgres server and the data for the product that was chosen through the drop-down boxes is fetched. We further proceed to calculate the optimal price as discussed before. Next slide, please. So after the creation of the front end, we used Heroku to deploy it. First, we upload all the files to GitHub. Afterwards, we create an app in Heroku and connect it to GitHub, from where the Heroku app can directly access the code. We also need to create a requirements.txt file containing the necessary Python packages and a proc file which contains the instructions to Heroku stating how the code should be processed. After linking the app with the code, Heroku builds the code and deploys it to its server. And we can easily access the application using the link that Heroku provides. This is the link of our application. Now Rishal will continue with the presentation.
Now we can see an output video of the deployed web app. First, we choose a category from the category drop-down list. So there are so many categories in this category list. We choose standard rice. After the category is selected, a list of brands in that category will be populated in the brand column. From this, we select our required brand and head on to choose the product and zone of the business. You can see the MRP for different price. I mean, MRP range for the product is displayed, from where we can enter a MRP. And after entering the MRP and clicking on get price, you can see that the machine learning model is working, it's running, and then the output is shown. So now the optimal price for GH rice pulao 5 kg is 381 rupees, and it can be given to customers for 45.4% discount while generating 32,907.3 rupees of revenue on a sales unit of 1045 GH rice pulao 5 kg units. Yeah. So coming to challenges that we faced in this project are less number of data for some products. The more data we give the more data we give to a machine learning model, we can build a better OLS model. So dealing with outliers was another challenge that we faced. So since we had 2,357 unique products, dealing with all the outliers for each product was a challenge for us. So, and then Heroku only allows 10,000 rows of data to process in the free version. Next slide. So yeah, as we did in the output video, likewise, we can find the optimal price for any given products, and also the code has been created in such a way that new entries are also considered. So coming to future scope, along with this project, if we can add the concept of time-based dynamic pricing and market basket analysis, we can draw a much better insight on the given set of data. Next slide. So these are some of the websites that we have referred for the completion of the project. Yeah, so that was all about price optimization. Now, please type in your queries in the chat window so that we can answer if it is in our knowledge. Waiting for any questions. So I think we don't have any questions as of now. So let's proceed. So thank you so much for your help and support. We thank 360DigiTMG for providing us this wonderful opportunity with this project, and also InnoDataTix, as we can work with InnoDataTix too. So thank you.